Alright, in this video I'm going to go over Objective 2, determining the average rate of change if given a table. Remember, functions can be given to you as an expression, a table, or a graph. And then I'm also going to go over determine the average rate of change if given a graph. Pretty quick and easy ways to go about this. Again, the first step is always to identify my y2, so I'll write first step, and then the formula for rate of change is change in y is y2 minus y1 over x2 minus x1. So your first step is to identify those four pieces. I need a y2, a y1, an x2, and x1. Now usually, in this case, the x's will be given to you. The inputs will be given to you. You need to tell me the outputs. So for A, if I was going to do example A, I'm going to have you try B and C on your own. Example A, though, I have two inputs, x is 0 and x is 2. I need to then locate on my table over here, when x is 0, the x input of 0, the y value, hopefully you remember now, f of x can also be considered the output, which also can just be considered the y value. Any value that is labeled f of x is also the y value. So at 0, so I'm going to write it in coordinate point form. At 0, the y value at 0 in this case of this function is 5. So again, listed first is my x1, and this is x2. So I'm going to identify x1, which means this is y1, right? Input and outputs are pairs, they go together. So if it's the first input, it has to be the first output. Now, at 2, if I reference my table, at 2, the output is -3. So this is x2, and this is y2. So the first step is done. I've identified all four pieces of my average rate of change formula. Now I just have to input them into the formula. I'm going to put parentheses around any negative number I see. So that means that y2 is negative. It is a -3. So I'm going to do, this is step 2, actually solving for it. -3 minus my y1, which is 5, over my x2, which is 2, minus my x1, which is 0. At times, and this might be pretty simple to some of you, but so you might want to skip these steps and not identify them, and that's fine, but I would very much recommend labeling, and identifying the pieces, because if you ask me a question of how you did the math wrong, and I see that you didn't label anything or identify them or lay it out like I have written here, I have a hard time answering that question because I don't know where you went wrong. Alright, let's do the math then to solve this or to simplify this. -3 minus 5. Consider it you owe $3 and you borrowed 5 more, which means you're going to be more in the negative. So this would be -8. Over 2 minus 0, in that case, is just 2. And rate of change can always be simplified. Well, not always, but if it can be simplified, I want it to be simplified. So -8 divided by 2 gives me a -4. So two things jump out. It's a negative number, so I know that the graph or the picture format of this function is going down at -4, and it's going down at a rate of 4. So go ahead and try B and C. You need to identify the four pieces, y2, y1, x2, x1, insert them into the formula, and then solve the formula. After you're finished doing those examples, so I'm sorry, please pause the video and go ahead and try example B and example C. When you're done with those, you can reopen the video and work on Objective 3, which is determine the average rate of change if given a graph. Again, this is the first step. Never differs. I have to identify the y2. I'll put it right here. y2, y1, x2, x1. That is my formula for rate of change. So if I was going to do example A, my first step is to identify just that, my x's and my y's, my inputs and my outputs. The inputs of x's are given to you. The first one listed is 1, so I know that to be x1. I have to find then its output. Now I'm going to reference the graph. I need to find x equals 1, which is right here. Now at x equals 1, it's a unique situation because the y value, if I were to go up or down, doesn't hit anywhere except for also right at x equals 1. And so in this case, the y value, y1, is also 1. The second input is 3. That's my x2. So I need to reference my graph. At 3, I'll put a little x there. That's my landmark. At 3, I see that the y value is down here, and the y value is -4. And I know that to be y2. Now that I've identified the 4 pieces, the math and how I enter it into the formula is the same. I just write my y2, which is a negative, so I'm going to put it in parentheses, negative. I hope to see you guys get in the habit of putting parentheses around negatives just to keep it separate. So y2 minus y1, which is a 1, over x2, which is 3, minus 1, and then I just solve. -4 minus 1, I owe $4 and I borrow another one, so I'm going to owe more money. In this case, I owe $5. So -5 over 3 minus 1 is 2. This is an instance where it cannot be reduced. 5/2 cannot be reduced. So that is my final answer. -5/2 is the rate of change. And what happens with a graph is you can actually see it happening. So from x equals 1 right here to x equals 3 right here, I'll highlight it in blue. You can actually see that highlight it in green. The graph from that x values, those x values, is indeed going down. And it's going down by an average of -5 over 2. So graphically it gives you a good picture of it. It's going down, so that means it's negative. So graphs are very important. And you'll be able to reference this throughout the semester.
Hannah?
Alright, so go ahead and try this one, example 1 right here, and also this one on your own. And then to finish up, when you finish, we're going to work with partners to do these final ones. They're just like the example that I did up here. No, right here, where you input something into the function. You input a x value into the function, it gives you a y value. The only difference is the function has 2 x's. If you notice, there's an x squared and a 4x.